Warning: this video contains clips and excerpts of a humorous nature not normally found in math class. These are intended to fight the adolescent condition known as short attention span, found heavily in the modern teen, especially when in school. The only thing you should attempt at home is the math. The rest, you just laugh at. Hi, welcome back to another edition of AT Math. Today, we'll be covering 4.2, Relations and Functions. Why this is almost important as proper gun safety. I do hope he's okay. Alright, let's begin. So 4.2, Relations and Functions. The rule of the day. Every x must have only one y. We're going to find the relationship between each x and its individual y. In other words, every input has exactly one output. This way, when we know what the x is, we should know what the y will be as well. Example. Suppose you pull up to McDonald's. Okay, maybe not on this. How about more like this? Okay. So how does it work? Well, you know how it goes. Well, you drive up and tell them what you want to eat. Well, what you order or what you say is the X, because you decide. There's an entire menu to pick from, and you choose what you want to eat. Now, based on what you ordered, they tell you how much you got to pay, which is the Y. So let's do next page, and I'll show you. If you order a small amount, say you only order 2 apple pies, well, then you pay a small amount, like $1. But let's say you order, 4 extra value meals. Well, then you're going to pay a lot. You're going to probably pay over $10. So the point is, you control what you want to order. Then they control how much you have to pay for it. The reverse wouldn't make a lot of sense. I mean, imagine instead you go up to the drive-thru and give the person at the window a $10 bill and say, "Hey, surprise me." That ain't going to work out too well. It's the way it has to work. Imagine instead there is no fixed price item. Instead there is no fixed price for an item. So we're going down, say, to the lunchroom downstairs. All right. You know everything in the lunchroom has a certain price. Either you buy the meal for a certain amount, or you can buy bits and pieces, or what have you. But there's always a fixed price per thing. So the first person says, "How much for a slice of pizza?" Let's say they're charged $1. All right, it's a good value. Now the second person comes up and says, "How much for a slice of pizza?" And they're charged 10 cents. That's really good. But then the third person says, "How much for a slice of pizza?" And they're charged $20. Yeah, even the cat's confused here. Now, I don't know about you, but if I was the guy who was charged $20, I'd be pretty mad. Plus, I'm not sure if I'd even want to order pizza if I didn't know how much the price was going to be. If it was going to, go from a dime to $1 to $20, you never know what you're going to get, because who knows what I might be charged. This is obviously a crazy example, as prices may change, but normally they're about the same amount. For instance, the McDouble is usually $1. And so if you buy 3 McDoubles, you're going to pay $3. If you buy one, you'll pay $1, and so on and so forth. You basically have a good idea of what you have to pay. So, if x, then y. X is what you call the independent variable, which simply means you choose. Based on what you choose will determine what you're getting, but the dependent variable is the reaction. It's the result. So basically, action, reaction, cause, effect. All that comes into play. Now, every day, you have thousands of choices you make every day. Each choice and action leads to a new reaction. This reaction then sets up new choices that need to choose, and the cycle repeats. So every day you actually help set up most of your day based on your actions. If you didn't wake up for school on time, then you might be late. You might have to have your parents drive you in. You might get into an argument about it. Your whole day could be messed up. On the other hand, let's say you get your homework done on time and you're ready for your test, and you take a test and you get a good grade. The good grade in turn lets your parents give you a raise in your allowance. All these good things happen because you started making good choices. So bad choices usually lead to bad reactions. Good choices usually lead to good reaction. Not always, but usually. That's your public service announcement for the day. Now let's go back to my example here about independent and dependent variable. Suppose you're invited to go to a football game on Friday, or you can choose to stay home and watch TV. Well, let's say that you decide to go to the football game, And while you're there, you start to talk to another friend of yours who also is at the game. When the friend sees you, they'll say, well, hey, my mom's taking me to Pizza Hut after the game. You want to come? You say yes, and you get to feast on Pizza Hut pizza that evening. Now, had you not elected to go to the football game, you would not have seen your friend, and therefore you would not have had the chance to go out to Pizza Hut that evening with them. On the other hand, let's be fair to the person who stayed home. You're invited to go to the football game on Friday, but you choose to stay home and watch TV. Let's say you decide to stay home while you watch Degrassi on Nick. You see an ad for Affleck with a pigeon saying Major Medical. The ad makes you laugh, and you practice saying that all night. The next day you repeat that to all your friends, and you get laughs all day. Say, here, what's this right here? Let me click it and find out.
Why do we have Affleck?
Affleck?
And Major Medical?
Major Medical boy, yeah! I help pay the doctor. Ain't that enough for you?
There are things Major Medical doesn't do.
Affleck!
Pays cash so we don't have to fret.
Something families should get.
Like a safety net.
Even helps pay deductibles to cover your back with.
Help protect your family at Aflac.com.
I should be calling Affleck getting a endorsement or some money for showing that on my commercial, but that's okay. So either way, the choices you make, which is X, determine your result, which is Y. Let's go ahead and take a short commercial break.
Hello. Hello.
And we're back. Now, dealing with X and Y variables, it does not matter what Y becomes so long as it always is that from that particular X. In other words, it doesn't matter that when X is 15, Y is 20, except that when X is 15, Y is always 20. And if X is 14, Y is 22. If X was 3, Y is 1043. It doesn't matter if we understand why it is. All that matters is that we understand that this gets us this. Option 15 will get us result 20. Option 14 gets us result 22, and so on and so forth. We just have to know that this gets you that. At this point, it's not important to know how these particular X's become the Y's. They become, I just mentioned that. All you got to know is that when X is 15, Y becomes 20, etc., etc. Because each X has only one Y answer, it is called a function. In other words, we understand the connection between the two. Like this will get you this will get you this, and so on. Meaning that each X only has one individual Y answer. Now this is okay also. Now if you look here, wait a minute, you're like, but these all have the same Y's at the end. But that's okay, because if you say that you're going to put in 15, your answer is 5. Put in 14, the answer is 5. You put in 3, the answer is 5. Put in 10, the answer is 5. Kind of like voting, for just one person. No matter who you vote for, that person is going to be elected. Ask your parents about communism, Soviet Union. They'll probably tell you about it. All right, so even though each Y is 5, that's okay, because every X still gets me one individual answer. When I press 15, 5 is going to pop up. Just because 5 pops up for every single one ain't the point. I know when I press 15, 5 is my result. But here's what's not a function. If you take a look here, when 2 you get 12, when 3 you get 7, when 7 you get 5, when 3 you get 13. At first it looks like there's a path, but if you notice there are 2 different 3's and 2 different outcomes. So in this case, when X is 3, what's Y? Well, here 3 was 7, but here 3 is 13. So it's kind of like saying, well, which one am I going to get? It'd be kind of like, you not know which one to take. And you never know which one's going to pop up because there's 2 separate possibilities. So in this case here, 3 gives you 7, 3 gives you 13. Since we don't have an exact answer and it could be one of the two, it is not a function. Now there are different ways to show this data. The most common, of course, is a table. Now we've covered a table enough that I think you know what that is. However, another's called a mapping diagram. It's basically the same thing, just shows a mapping. In this case, from 1 gets you 3, 2 gets you 6, 3 gets you 7, 4 gets you 9. The one thing about a mapping diagram is you can go ahead and have different arrows like this. So 1 can reach down to the 7, and 2 could be the 3, and 3, 7, 4, and 6. And normally they're ranked in order to kind of give you an idea of where they're traveling. And believe it or not, in this case, this is a function, even though 1 gets you 7 and 3 gets you 7, because each individual Y gives you an individual X, even though these 2 X's lead to the same Y. And of course, you have the graph. So X is the domain, which is the left-right. Y is the range. So if you take a look here at the x value, x starts at the x value of 2 and it goes to 4. And the y value is going from 4 and goes all the way up to an 8. We'll cover that here in a second. So we need to find the domain and range. We kind of covered that. The value of left to right goes from 2 to 4. So what you do is think of goalposts like we had with inequalities. Put a 2 here and a 4 here. Those are your goalposts. Put x in between because they're connected. Less than. Remember that? Remember less than. So hopefully you got that from last chapter. So 2, 4, your goalpost, x in the middle, less than or equal to, less than or equal to. I forgot the equal to part because you can include them as well. Now if you look at the y value, the up and down, we mentioned it's from 4 to 8. So fine, 4 to 8. But this time put a y in the middle, not an x. But because you're connected, less than or equal to. So you have that. The seams up down is the y value, 4, 8, your goalpost, y in the middle, less than equal to, less than equal to. So your finished answer is the following. The domain was between 2 and 4, so 2 less or equal to x less or equal to 4. Range 4 less or equal to y less or equal to 8. We use this method because anything from the x value 2 to 4 and y value 4 to 8 can be used. So anything in that grid is fair game. Here is another. If you take a look. Alright. So we're going to measure from left to right. Now it's kind of blurry, I admit, but 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 to the right. So think goalpost, -5, +5, x in the middle, less than or equal to. Y value looks like it's going from 0 down to -3. So okay, the range in this case would be -3 is 0, y in the middle, less than or equal to. Time for a quick commercial. And we're back. Alright, let's try a U-try here. Go ahead. Remember, look for the x value, then the y value. Go ahead. Let's see what you got. Mine is, and I'll put it up here for you. The domain I get is -4 because it's going 4 to the left and 1 to the right, so -4 and 1, x in the middle. And range went all the way down to -5, all the way up to +5, so -5, +5, y, less than, equal to. In this case, the domain and range, the domain is to 1, 2 is to 3, 3 is to 7, 4 is to 6. However, the maximum amount of the domain goes from 1 to 4. The maximum amount of the range goes from 3 to 7, but notice it just uses particular numbers. There's no 1.2 here. There's no 3.1 listed. It's just a 1, 2, 3, or 4. So the domain x value can only be 4 values, either 1, 2, 3, or 4. So you just write domain ... these little brackets. You just put 1, 2, 3, and 4 because those are the 4 choices. Just like a pop machine, if there's 4 different buttons you can push, well, okay, based on what you push, well, something's going to come out, but you only get 4 choices. So this is like 4 buttons on the machine. Now this is because anything in between these numbers cannot be used. Now take a look at this. Think of range here. Now the range might be the 3 outcomes. Now you might say, wait a minute, if I got 4 buttons, how can I have only 3 outcomes? Well, maybe 2 buttons are Pepsi. So it doesn't matter which button you push. If it says Pepsi, odds are Pepsi's going to tumble out of the machine as it's supposed to. Now, you push the Pepsi button and Diet Shasta comes out, that's a machine that's going to get beaten up. You're going to be knocking into it and driving, beating it up. But don't do that though, because machines can rock and fall on you, and then you die. Don't die over 60-cent pop, please. That'd be bad. So anyway, domain 1, 2, 3, or 4, but range is 3, 6, and 7. So R bracket 3, 6, 7, and the finished product is D : bracket 1, 2, 3, 4 bracket R : 3, 6, 7 bracket. Oh, I'm getting tired of this message there. I'll be fixing that for next message, for the next lesson. Let's do a U-try. Go ahead and put these in brackets, domain and range. Go ahead at this time. Let's see what you got. This and this. And you know what? Let's do a quick break.
Spider yelling.
Raw! Raw! Raw, raw, raw! Raw, raw! Raw!
And we're back. And the tables are the same. 2, 3, 4, 5, 5, 7, 9, 11. Now in this we have to assume that this here is the x value and this is the y value. If it doesn't say, how do you know? Well, if they don't give you anything, in lieu of that, I would put this as my x value as the first ones and y as the second. But normally they'll give you the value. So really x should have been here and y should have been here. So okay, x value 2, 3, 4, 5, which is your domain. Range 5, 7, 9, 11, which is right here. Finally, this time we will just measure the range of domain. Now how are you going to do that in a circle? We're just going to find the maximum and minimum. Hint, you're going to do that again in Algebra 2, Pre-Calculus, and Calculus, finding maxes and mins. So this ain't no different. What's the difference with Pre-Calc and Calc? You just do this stuff. It's going to be like a wavy line. But we're not doing that right now. I'm just giving you a preview. For right now, just find the domain minimum or maximum. Looks like the minimum, 1, 2, 3, 4, about -5. Forward 1, 2, about 3. So I'm saying that the domain is -5 to +3. And the range looks like it goes down to -3 and all the way up to about +5. So -5, +3. X in the middle. Range -3, +5. Y in the middle. Lesser than or equal to both sides. Good enough. We are done. Thanks again. A little quick clip before you go. I'll talk to you next time. Bye.
Ooh, piece of candy. Ooh, piece of candy. Ooh, piece of candy. Ooh, piece of candy.